All right, take a look at the first question that's similar to what's on the test. So, for this one, I want to find the vertices, foci, and center of the ellipse. So what I'm going to do is I'm going to give you the equation, and then you can give me all that stuff. So, let's do x minus 3 squared over 4 plus y plus 1 squared divided by 9 equals 1. Now, whether they give you the equation or they give you the vertices, foci, and center, what are the 5 letters you should always find first?
H, K, A, B, C.
Yep, H, K, A, B, C. All right, so remember H and K, that's your center. Okay? So H is always the number after the minus sign with X. K is always the number after the minus sign with Y. So what would H be here?
3.
3?
And negative 1.
And K is negative 1. All right. Now, for an ellipse, A is always the bigger number. Okay?
Okay.
It's different than a hyperbola. So these are A squared and B squared. So what would A be in this case?
3.
3 and B?
2.
2. Now, C is important because we need C to find the foci. What's the formula that connects A, B, and C?
C squared equals A squared minus B squared.
Yes. So for an ellipse, it's C squared equals A squared minus B squared. And then C squared would equal, A squared is 9, minus B squared is 4. So what does C come out to?
Square root of 5.
Yep, square root of 5. All right, so now we got all the important stuff. We can describe whatever they want. All right, so vertices. Let's do the center first. Okay, I'm going to do center. Where is the center?
3 and negative 1.
Yep. Now, everything else is either going to be above and below that center or left and right of it. They didn't ask us to find the major axis, but you kind of need it to figure that out. So I'm going to write down major axis. And which way does the major axis go in this ellipse?
Vertical.
Yep, you always look at where the bigger number is. Bigger number is under y in this case. So major axis is vertical. And now, let's do the vertices. So the vertices are going to be how far away from the center?
3.
3, yep. So 3 units away from the center, vertically. 3 units up, 3 units down. So what would be 3 units up from negative 1?
2.
2. And what would be 3 units down from negative 1?
Negative 4.
Negative 4.
So you just leave the first number in the same sentence.
It's not moving right because the vertices have to line up exactly with the center.
Okay, that's what I did.
Yep. So they're all going to line up vertical. So there's the center, the vertices, and the foci. How far are the foci from the center?
Is it the square root?
Yep, they're the square root of 5. And square root of 5 up and down. So up and down, that's going to be the y value. So x value isn't going to change, but we're going to take the y value and we're going to shift it up square root of 5 and down square root of 5. So those would be the equation of the coordinates of your foci.
Okay. Is that it? For the, that's what the problem would be.
And that was it. Yep. Find the vertices, the foci, and the center. Any questions on that?
No, I was just confused on the center and the vertices and the foci, but I got it now.
Make sense? Okay.
Yeah.
Perfect. Okay, so this one very similar to the last one, except the equation isn't going to be in the form we need first. So I just want to see if we can get it that way, and then from there the rest would be the same. Bless you. So let's say we had 4y squared plus 9x squared equals 36. What's wrong with that equation?
There's like the coefficient.
Okay, and what else is wrong?
Oh, it needs to be equal to 1.
It should be equal to 1. How would we make that equal to 1?
Divide by 36.
Yep, divide everything by 36. And 4 goes into 36 how many times?
9.
9. And 9 goes into 36?
4.
4. And 36 into 36 is 1. Now you've got an equation just like the one we did before,
Okay.
where we could get h, k, a, b, c.
Yeah.
Any questions on how you'd find all those from this point? Okay. All right, so let's look at this one. So now they want us to find the equation of an ellipse given some information. First thing you always want to do, hk, abc. All right, so h and k are the coordinates of the what?
Center.
Center. So what's the center here?
-1.
-1, 1. So we got those two. A is the distance between what two things?
The vertex and the center.
Yeah. And what's the distance between vertex and center here?
2.
2. Now, B in an ellipse is the distance between what and what?
The center and the minor axis.
So center to minor axis, which is
1.
1. And C is the distance from center to foci. So we don't have enough information to find C directly, but if we're going to just find the equation of an ellipse, do we even need C? No, C isn't part of the equation for an ellipse. Only if they wanted to know the foci would we need C. So we're ready to write the equation. Right. So I'm going to start with my two fractions equal to 1. Is it a plus sign or a minus sign between them for an ellipse?
Plus.
Plus. All right. And what letter always goes in the top of the numerator, first numerator?
X squared.
It's always an x squared. It's always a y squared. And now it's x minus what letter?
It'd be +1.
Right.
Yeah.
X minus h. So it would be x minus minus 1. And then y minus what letter?
Okay.
K, which is 1. Now, we have to decide where to put A and B. Which way does your major axis go here?
Horizontal.
Horizontal.
Put 2 under the x, or 4.
4. So A squared is going to go there,
Yeah, and then 1 under there.
and 1 is going to go here. And there is the equation for your ellipse.
Okay.
Any question on that? Okay. All right, so we're skipping over the hyperbolas, but the kinds of things you want to make sure you know about hyperbolas is if I give you an equation, how to find the center, focus, foci, and asymptotes. Or I might give you like vertices and foci and center and say, what's the equation? So one of each. All right. So the next topic on the test is determining if a coordinate is a solution to that system. How would you check if that coordinate is a solution to that system?
Plug the numbers in for x and y.
Yeah, just plug them in for x and y. So when we plug those in here, would that coordinate work in the first equation?
Yeah.
Yeah, because you get 2 times 1 plus 2 equals 4. And yes, 4 equals 4. So it works there. How about when we plug it into the bottom equation? Because it can't just work in one, it's got to work in both.
No.
No, because we're going to get -1 minus 3 times 2 is 6 equals 5. -1 minus 6 is -7. So it doesn't work there. It works here. So what is the answer? Is that coordinate a solution to the system?
No.
No.
It's not.
That's not a solution. Any question on that one?
No.
All right, let's look at this. Solve using substitution. So this is a problem where I'm actually going to give you a specific way that I want you to solve it, and it's probably going to be, one that is kind of set up to use substitution anyway. So let's say we had 2x plus y equals 8, and negative 3x minus 2y equals 5. Now, because I just made these up, it's probably going to come out to fractions. So we'll use our calculator if we need to. All right, so to solve using substitution, pick an equation, and which equation would be easier to work with here?
Probably the first one.
The first one? And what letter could you solve it for?
Y.
Yeah. So if you get y by itself, what would y equal?
Y equals 8 minus 2x.
All right, so we have 8 minus 2x. And now what would we do with that?
Plug that in the equation below for y.
Plug that in for y. And when we plug it in, we want to make sure that we use what symbol?
What do you mean?
So we got to be careful about how we write. Like, you tell me what I would write next.
2, and then in parentheses.
Yes, we have to make sure we put parentheses.
Okay.
Yep. And then 8 minus 2x equals 5. Okay. So how would I solve that?
Distribute. So the negative 3x minus 16 plus 4x equals 5.
All right. Actually, we're going to get a nice answer for x. So when you combine your like terms, what do you get on the left?
X minus 16.
Mm-hmm. So we're going to get x, and if we put the 16 on the other side?
21.
21. So x is 21. And now you'd have to plug it back in for x and find y.
I'm good with that.
No question on that?
Yeah.
Okay. Okay, so let's solve another 2x2 system.
Is that going to be like 1 with 3?
Yes.
You just do one of those?
No, you're good with solving 2x2 elimination?
I think so.
Okay.
I just don't know how to do the other one. Like the 3.
So 3, there's also going to be one, I might give you something like, let's actually look at this.
Amarante Camilla to the main office, please.
Solve graphically. So let's say I gave you y equals x cubed plus 2x squared plus 3, and y equals 8x. So that would be one that's really hard to do with substitution because it's a cubic equation. Even if you substituted in 8x for y, you'd have 8x equals a cubic. That could be kind of hard to solve. So how would I solve this graphically? What would I do?
Type both equations in and see where they cross.
Yep, so just type both equations in. So x cubed plus 2x squared plus 3. It's not really something we spent a ton of time on this week, but it's something we've done before. So we graph both. It's going to cross once, definitely. Don't think it's going to cross twice. Oh. I think it does. So what would I want to do here to check that out a little more?
Zoom in or change the window.
Yeah, I would set my y max, change the window to maybe like 25. So there's the cubic. There's that. Now, I can see that they definitely cross at least twice. Do you think they're going to cross down lower again, too?
Maybe.
It could, because this cubic is pretty steep. This red line is never going to change its steepness. So this might be one where people would lose credit because they'd forget to find the third one, because they might not think it happens.
So that can be more than one?
Yep, definitely can be more than one answer. And I think you'll be able to see here that there are definitely 3. So, yep, definitely. We just do second calc intersect 3 times and get all 3. Yep. So there's that. Any questions on the special cases? Because you're going to have something with that. Like if I said, does the following have 1 solution, 2 solution, no solution? Would you know how to figure that out?
I think so. Like, would we have to solve it and then write?
Yeah, you could start to solve it. Or if it's a simple equation like lines, if 2 lines had no solution, what would you be looking for in their equations? System with no solution. What would that mean when you graph the lines?
That they never intersect.
They never intersect. So what would you look for that tells you 2 lines never cross?
They don't have like an X or Y.
Well, let's just look at these two. Y equals 3x plus 8. Y equals 5x minus 12. Would those lines cross? There's a quick way to, you can look at one thing.
If they're not parallel or...
And how would you know if they're parallel or not?
They have the same something.
Same something.
Coefficient.
And what is that number? It's the coefficient of x, but it stands for something when you draw a line. It's the something of the line. Slope. So if you look at the lines and you have 2 lines with the same slope, then you know that's a no solution problem.
Okay.
All right. Here, they have different slopes, so they're definitely going to cross. Now, what if I had this? What would be the solution here?
Would it be no solution?
This one's not a no solution. So what method could you use to solve this one? It's already kind of set up for it.
Substitution.
So y is already by itself here. So where would you plug that in?
In for Y.
In for y. And now if you did 2 times all of that, what would you get?
Oh, would it be infinite?
This would be infinite, because you get 4x plus 16 equals 4x plus 16. It's the same thing on the left and the right. So these 2 lines actually have the same slope, but they also have the same intercept. So same slope, same intercept, same line. Same slope, different intercept, parallel. Different slopes, 1 solution.
Okay.
All right, so that's the special case stuff. And then the last part is solving a system using the Gaussian elimination. And did you have a question on that?
Is that what we did then?
Yes.
Yeah, it's kind of confused.
Okay. So let's solve using Gaussian elimination. Okay, so you got this equation, or system to solve. A lot of times you would probably see it written like that. So if you see a blank there, then it's your job to fill in 0y. Okay. First thing we want to do is just translate this to a matrix, so we don't have to deal with all the letters. What would my first row in the matrix be?
1, 2. Oh wait, row.
Yep, first row.
1, -1, and 1. And then line. 0.
0. Yep, and second row?
2, 0, -3, and then -1.
And the last row?
-1, -1, 2, -1.
Okay. So when we start, what is the first element in that matrix you want to focus on? In what row, what column?
Row 1, column 1.
Yep, row 1, column 1.
And the second terms. Or The first element has to be 1.
And you want that to be a 1. So what would you have to do to make it a 1?
Nothing.
Nothing. It already is. So we don't have to worry about that. So now, what's the next element in this matrix we look at?
The 2.
The 2, right? Row 2, column 1. You want this to become a what?
0.
0. What else do you want to become a 0?
The -1.
Where?
Below it.
Below it. So we want these two things to become zeros. So what could you multiply row 1 by to make a 0 in row 2?
-2.
Yep. So let's write that down. I'm going to do -2 times row 2. -2 times row 1. We're going to add that to row 2. And where are we going to put that answer?
In row 2.
In row 2. We're going to replace what's in row 2 with that calculation. Now, what could we multiply? What would you have to multiply row 1 by to make a 0 down in this spot?
1.
1, yeah, you don't have to multiply it by anything. You really just need to add this row to that row, and you'll get a 0 automatically. So we're going to do row 1 plus row 3, and where are we going to put that?
Row 3.
Row 3. Okay. So what are we doing to row 1?
Nothing.
Nothing. So we got 1, -1, 1, 0. All right, now let's do the calculation. Multiply everything in row 1 by -2 and add it to row 2. So what's 1 times -2?
-2.
Plus 2?
0.
0. -1 times -2?
2.
Plus 0.
2.
2. And 1 times -2?
-2.
Minus 3.
1.
-2 minus 3?
Up.
Not plus 3.
-5.
-5. Yep. And 0 times -2?
0.
Plus -1.
-1.
-1. All right, and now we got one more row. In these two rows, we're just adding 1 plus -1?
0.
0. And then -1 plus -1?
-2.
-2. And 1 plus 2?
3.
3. And 0 plus -1?
-1.
-1. Okay, so now we've got the first column. We're good. What's the next number you look at in that matrix?
The 2s. And
Okay,
then
which two?
the 1 in the second.
Yep, 1 in the second row. And you want to make that what number?
A 1.
Want to make it a 1. So how could we make that a 1?
The first row times 2.
We want to be careful, because if we do anything with the first row, it's going to mess up these
Or
zeros.
the -1.
Do what again?
The -1 and then above the 2.
So you're going to use this first row? So if you remember, if you use this first row, like if you multiply this row by something and add it to this row, you would make that a 1, but you're going to mess up that 0.
Yeah, I don't know what to do at this part.
So do you see why that wouldn't work though?
Yeah.
Because a lot of people would try that and they'd say, oh, just multiply this by like, you know, just add this row to this row, and then if you do that, it makes that a 1, but then it makes that a 1.
Mm-hmm.
Now we're messed up. So now it's like we have to start over again. What's another elementary row operation? You've multiplied rows by a constant. So we've multiplied rows by a constant. So we did that back here. Is there anything you could multiply row 2 by to make that number a 1?
Half.
A half, yeah. So we're going to just multiply everything by a half. And that's all we're going to do in this step. So we can take half of row 2 and replace what's in row 2. So what would I write down for row 1?
It'd be the same.
Same? What would I write down for row 2?
0, 1. half of 5.
All right, let's just leave it as negative 5 halves.
And then, wait, negative half.
Mm-hmm. All right, and now what would I do for row 3?
Leave it.
Leave it, unless you want to get fancy and try to do 2 things in the same step, but then
Yeah.
you might get a little lost doing that. Okay, so now we've got 4 out of the 6 things the way we want them. This one, this one, this one, this one. What's the next thing we want to look at?
You have to make the 3 a 1. Or oh wait, no,
something
negative
before that.
2 is 0.
We have to make this a 0.
Yeah.
So what row are you going to use to do that?
The 3rd.
Well, we're going to change the 3rd row, but what row above it are you going to use to change it?
The 2nd.
The 2nd. You don't want to use the 1st because you got that 1 right there. That would mess other things up. So we're going to use the 2nd row.
So for when you're changing like the 2nd row, you use that number? Like you don't use a row above it?
When you're changing what row?
Like the one we just did.
The one we just did? So yes, when we changed the 2nd row, we used the one above it. So you always use the one above it. Remember when we changed row 2, we did row 1 times something.
Yeah, like the other one though, like when we're changing the 2 to a 1.
When we changed the 2 to a 1, we didn't use any rows to change that.
Okay.
We just multiplied by a half.
Okay.
So that didn't involve the row above it or the row below it.
Okay.
Yep. Now we're going to use the row above to make that a 0. So what would you have to multiply row 2 by?
2.
2. So we're going to take 2 times the 2nd row, and what are we going to add that to?
The 3rd.
3rd. And where are you going to put this answer?
In the 3rd.
In the 3rd. So what would I write down for row 1?
The same.
Same? 1, negative 1, 1, 0. How about row 2?
The same.
Same? 0, 1, negative 5 halves, negative a half. And now, how about row 3?
0.
Yep, because 0 times 2 is 0, plus 0 is 0.
And then another 0.
And then another 0, because 1 times 2 is 2, plus negative 2 is 0. And now, last part, we're going to be a little careful. What's negative 5 halves times 2?
Negative 10 halves, so 5. Negative 5.
Negative 5 plus 3.
Negative 2.
Negative 2. And the last one, what's 2 times negative a half?
Negative 2 or negative 1.
Not negative 1.5. Well, how about just 2 times a half?
So you're plugging that into. Like,
You're just multiplying everything, you're basically doubling everything in that row and then adding it to the one below
so
it.
1.
Yeah, so that, well, negative 1.
Yeah.
So double negative a half, you get negative 1 plus negative 1.
Negative 2.
Negative 2. All right, so now we're down to our last step. So what is the last number that I have to change?
The 3. Or the negative 2.
Yes, the negative 2. And what do you want to make that number?
1.
1. So how would we make a 1 in that spot?
2 times the 2nd row.
So be careful, because if you use the row above it and you do something to that and bring it down, there's a 1 above it. So this 1 would mess up that 0.
Okay, so then you don't use a row?
You can't use another row to help you get a 1 there. When you're getting the 1s, all you really want to do is multiply a row by a constant.
Oh, okay. So times 2. Or, no, times a half.
Times, close, not a half.
Negative half.
Negative a half. So row 3 times negative a half And where are we going to put that answer?
In the third column.
Third row. Okay. What about rows 1 and 2?
The same.
Stays the same. So 1, negative 1, 1, 0. Now, just multiply everything by negative a half. 0 times negative a half.
0.
And then 0 times negative a half again.
0.
And negative 2 times negative a half.
1.
And negative 2 times negative a half.
1.
1. So now, what does that last row say if you wrote it out?
So now z equals 1.
Yep, z equals 1. What does the row above it say?
Y minus 5 over 2 z.
Yep, equals
Negative a half.
negative a half. Now we're plugging in 1, so what's negative 5 halves times 1?
Negative 5 times.
What is it again? Negative 5 halves times 1?
Over 2.
So when you do that, what did you, I'm not sure I heard what you said.
Wouldn't it be the same?
Yeah, it just stays the same. Yeah. Yep. So negative 5 halves. And what would be on the other side?
Negative a half.
Yep, negative a half. So now what would be our last step?
Subtract the 5 halves. Or add it.
Add it, yeah. So negative a half plus 5 halves
So it'd be 2.
would give me 2. So now we got z, we got y. What's the last thing we got to get?
You just plug that back.
Yeah, plug that in, and that would give us x. Any question on how you would find x? Or you want to finish it?
No, it's okay.
You're okay?
Yeah.
All right. That one wouldn't have any fractions, so it would be just 1s and negative 1s. It'd be a little easier.
Okay.
So we ended up with these fractions in the middle, which was kind of a pain, but we still got nice answers. But that's how it'll probably be on the test. So unfortunately, if you make that one mistake, like, you add or you accidentally say 1 when you mean negative 1, it gets really bad. So you just have to go through very carefully and maybe almost like OCD, like do it and then just like do it again and double check it to try to, just be as careful as you can.
Okay.
Right, so any other questions?
No.
Okay.
Thank you.
Yep.